Hello guys, welcome back to Med Zone African Motives. We are still on our integration. This is the most important topic actually. You're going to see that integration and also the derivatives, like the whole of your syllabus is just integration, derivatives, integration, derivatives. That's the whole of your syllabus. So it's interesting in N6. Anyways, this is integration of trigonometric functions of the type sine to the exponent of n(ax) with respect to x, and the integral of cos to the exponent of n of ax with respect to x. So we want to see how can we be able to integrate such trigonometric functions. As we know that we are dealing with trigonometric functions, so what it means is that we are supposed also to be related with our trigonometric identities, all right? Back to your trigonometry, your identities, all of the identities that you are given, you are supposed to be very, very familiar with these identities, all right? So I'm not gonna explain much because what we have is that, guys, this is N6. We have been talking of these identities from our N5. So I'm not gonna we are intrigued, or we've been giving this since N4, you still remember. And also the advantages that we have, they tried by all means to just list a lot of identities. They tried by all means. So there's no identity like you're gonna be looking to say, which one is it that I need? Even from tan x, guys, cos x, which is one of us, they tried by all means. So these are the identities that you have. All right. So I'm going to explain about these two identities here. Like I say, the advantage is that we have this in our simplification. All right. Let me just try to reduce like this. All right. This one. We have this part. All right. That I want to explain in detail. All right. So I'm just going to use x. Yes, is given in terms of a. Which is fine, all right? I'm just gonna have these identities here. So whenever we are working with these integrals, we have these identities that I showed you here, and this part, and also this identity that we are used to from our Pythagorean identity, the identity of sine squared x, cos squared x plus cos squared x, which is equal to 1. So like most of the cases we are used to the use of the x, because I'm just going to explain in terms of x. So this is an introduction. So what you need, guys, is that you need to understand, one, the n that you are given in our syllabus is going to be considered to be less than or equal to 5. Meaning to say we can use any n that we can think of, but this n is supposed to be less than or equal to 5. So on these numbers, let's consider our n to be 1. If n is equal to 1, it's a normal part that we're talking about. It's a normal integral. If this n is 1, guys, just like the integral of sine 2x with respect to x. So we're not going to waste much time of that because this is a 1 here. So the integral there is just direct. To integrate sine, remember sine changes to a negative cos. So it's going to be negative cos of 2x. We divide by the trig, the number that is affecting here, which is 2, all right, plus the constant of integration. We have all these integrals from our formula sheet. All right, so what I'm going to explain here is when these exponents are not 1 or 2. Why not 1 or 2? Because if this is a 2 and I want to integrate, let's say, sine to the exponent of 2, all right, and this is maybe 3x with respect to x. Yes, I can go back and use those identities, but in our syllabus, we have this advantage here. I want us to go back here in our formula sheet. So once you understand your formula sheet, you see that most of these things, you're not gonna worry about them because already we have this. All right, so I want us to go here. If you check here on top, all right, these are derivatives, all right? These are derivatives, okay? I want us to concentrate on integrals because we are on integration. We are integrating f of x with respect to x. So I want you to see something here. if you check below, there we are given the integral of sine squared ax, cos squared ax, tan squared ax, even for cot on the next page. So meaning to say, we have these, like that part that we're integrating sine. So it means for sine ax is going to be, you're going to use this formula. So there is no need. That's why I'm saying here, in your simplification or in your integrals that you're going to have, there is no need for you to worry about knowing how to integrate sine to the exponent of 2. So on these exponents that we have n, the most important, we are going to start with n is equal to 3, n is equal to 4, or n is equal to 5. Because if n is equal to 1, we saw that is a normal integral. If n is equal to 2, it's also a normal integral because we are given these integrals, right? We saw that the integral of sine squared, it was given like this. The integral of sine squared ax, like this. This integral is with respect to x, all right? It is given as x over 2 minus sine 2ax, all right, from our formula sheet, the part that I was showing you guys, over 4a plus c. So meaning to say, if I'm asked to integrate sine squared like this, 3x, I'm just substituting what is the a here, ax here. That is the most important part. The part representing ax in this case is 3x. So meaning to say a is equal to 3. A is represented by 3. So wherever we see a, we are going to substitute 3. That is what you're going to do in this case. So this is going to give us the integral of sine squared 3x with respect to x is going to give us x over 2 minus the sine of 2ax. So this is 2 times ax. Remember, our ax is 3x. So it's going to be 2 times 3x. Everything over 4a. Remember, I said a here is equal to 3. So that is 4 times 3 plus the constant of integration. So this is what you're supposed to have in actual sense. So you're going to have x over 2 minus, this will be the sine of 2 times 3, which is 6x over 12. 4 times 3 is 12 plus the constant of integration. So as you can see, if it was like this, it is something that is direct, so much direct. So much direct. So it is important for you to understand this. The exponents that we are concentrating with that are important is 3, 4, and 5, like I explained here. For 2 and 1, do not worry. It's something that is direct. 2, we just use the formula sheet. But now, if this exponent is 3 or 4 or 5, okay, let's start on a condition that this exponent of n is an even number. Let's start with even numbers. All right. So on a condition that whether it's for sine or it's for cos, all right, whether it's for sine or it's for cos, all right. Let me just reduce a little bit. Sorry for that, guys. I just want you to properly see here. It's like too much. This is too much. All right, I'm just going to write here. Remember, I said we are taking on a condition where n is an odd number. Let's start with an even number so that it can be easier. All right, 2 or n is equal to 4. These are the even numbers, whereby this exponent is an even number. Is an even number. So remember, we are dealing with the integral of sine to the exponent of n ax with respect to x. So meaning to say, if this n is an even number, that's where we are talking about being 2, being 4. These are the even numbers that we have less than or equal to 5. These numbers that we're talking about, they are less than or equal to 5. So this is it. Whenever you are working with this condition where these are even numbers, the exponent is an even number, n is equal to, you are going to use the identities, all right? I showed you those identities before. So on that condition, you are going to use these identities, the sine squared of ax, the sine squared of ax is equal to the half minus half cos of 2x. All right, 2ax. So if you check properly, I talked about this. Let me show you back. I'm just gonna show you back here. I explained about this. Is it the one? Let's just, oh no, this is for the integral. I need I need trig. All right, I just need the part of trig. I want you to see this. All right, I explained it here on top here. This is what you're seeing here. On this identity here, it's given this way. I want us to be together. It's given as the sine squared of A is equal to half minus half cos 2A. If this is a 2, take note, this is a 1. So what does it mean? If this is a 2, we're going to multiply by 2, this will be a 4. If this is a 4, we multiply by 2, this will be 8A. So what it simply means is that if this is just maybe AX, like the way that I wrote there, you're going to multiply the number on the other side by 2. So the way it is given on your formula sheet, you have to be careful. It's cos squared A, it's whatever that you have, but on the other side is 2A, you multiply by 2. This is the same way that I wrote here. If you check it properly, I'm writing it as sine squared AX. We are used to this. This is AX, the way that we have it here, all right? So it is going to give us a half minus half cos 2AX, meaning to say you multiply AX by what? By 2, okay? Then if it is for cos, it's going to be cos squared. AX is equal to a half plus a half of cos 2x, 2AX again. All right, these are the identities that you are supposed to think of, all right? Whenever the exponent is an even number, you're supposed to think of expanding this way. But like I said, if this n is equal to 2, there is no need for you to expand. You just use what? The formula sheet. Okay, let us prove something. If this is true, let us say we are given to integrate. I'm just going to take something basic. Let us say we are asked to integrate sine squared x with respect to x. N is an even number there. 2 is an even number. So if you were to check this, they're saying we are supposed to expand this in this way. Sine squared is equal to this. So meaning to say, if this is sine squared x, if this is 1, it means here we're going to have 1. So it will be 2x, 2 times 1x, which is 2x, which is cos 2x. Take note, guys. The A here is the number. So if this is 1, this is going to be multiplied by 1. So it will be 2x. If this is 2, this will be 2. So it'll be 2 times 2, it should be 4x. All right? So you multiply whatever that you have by what? By 2 on the other side. Here there's a 1. So you multiply it by 2 on the other side. So it's 2 times 1, which is what? Which is 2x. So this is what we are having. So meaning to say, this is going to be equal to, a sine is going to be a half. So this is going to be 1 over 2 minus 1 over 2 cos 2AX. So this is going to be cos 2 times. Now, what are we multiplying? 2 times what? What are we multiplying? 1. So it's 2 times 1, which is 2x. So this will be cos 2x. So this is what we have, like from sine squared. We are expanding sine squared. Take note, we are expanding what? Sine squared. But what is it that we are doing? We are integrating. So we are going to integrate this with respect to x, all right? So we are going to integrate this whole part with respect to x, like this. This is what we have now. Let us integrate and see. We are using the identity, all right? If we integrate half with respect to x, it's a constant, so it's going to be half x. So this will be half of x minus the integral of cos. Remember, cos changes to a sine. So that will be the sine of 2x over 2. We divide by the number that is affecting us, so we divide by 2. All right, plus the constant of integration. So that's it. Let us just simplify a little bit. This is going to give us half of x. All right, minus, so here we are going to have 1 times sin x, we multiply, this is same as over 1. So it's 1 over 2 times 1 over 2, which is 1 over 4. So it's going to be minus 1 over 4, right? Or just multiply the numerators together, which is going to be the sine of 2x. Everything over 2 times 2, which is a 4, plus the constant of integration. So this is half x, which is same as x over 2, right? Then this is sine 2x over 4, which is same as minus 1 over 4 sine 2x. Now, I said there was no need for us to introduce this identity here so that we can be able to integrate a sine squared. No. Because we saw that from our formula sheet. All right. From the formula sheet, we want to see if we're going to have the same thing here. We saw that from the formula sheet, we are given this as, remember, we are supposed to integrate sine squared x with respect to x. And we saw that the formula, I wrote this formula before. We saw from the formula sheet, it states that the integral of sine squared ax with respect to x is equal to, all right, this is sine squared ax with respect to x is equal to x over 2 minus the sine of 2ax. This is the sine of 2ax over 4a plus the constant of integration. This is a formula that is already there given for sine squared. All right, I explained this. Let us just go back. Let us just go back for the case, for the sake of, all right, for the sake of revision. Let us just go back here. It's already given in terms of what? Of sine squared. As long it's a sine squared that you are working with, as long it's a cos squared that you're working with, only when it is for a square, you can use this identity. So this is the one that we're going to apply on this side. All right, let's use our identity and see. So meaning to say, on our integral here, we saw that, all right, the integral of this is going to give it's going to give us this. So that means here the integral of sine squared x, it means our a in this case is a 1. The number that is affecting x is a 1. So if this is a 1, it means where there is a, I'm going to put a 1. Where there is a, I'm going to put a 1. So we are going to have the answer. Remember, the answer is this part. X over 2 plus the minus this. All right, so it's going to be x over 2 minus the sine of 2ax. So it's going to be 2 times ax. Our ax is 1x. So this one is just going to remain as 1x over 4 times a, which is 4a. A is 1 in that case, okay? Plus the constant of integration. So this is going to give us x over 2 minus the sine of, all right, this is a division for everything. Sorry, this one is affecting everything here. So this is the sine of 2 times 1x, which is the sine of 2x. Everything over 4 times 1, which is 4, plus the constant of integration. This is what we have from the formula. And as you can see, it's direct. It's just substituting direct from that integral. So this is what we have, which are the same answers. But here, we used exactly what is required in our integral to use the identity for sine squared. But because we have this in our formula sheet, so there's no need for us to use these identities when it is a squared. That's why I said when n is equal to 2, it's not important. It's important now if our n is 4. That is the even number that we can talk about, that we can think of. So I want us to talk about that condition. If our n is given as an even number, how now are we going to operate this, or how are we going to solve such typical questions? All right. I have got a question here that I want us to check. All right. I'm dealing with n being an even number, so I'm not going to remove this part so that we properly move together. Because I'm going to need these identities. I'm not going to remove this. I'm just going to write something that is having n. Let's say you are asked to integrate sine to the exponent of 4. All right, let's say we are given to integrate sine to the exponent of 4 of 4x with respect to x. This is what you're given. Okay. Like I said, whenever we are dealing or we are working with an even exponent where n is equal to 2 or n is equal to 4, where we have got even, and I said it's important only when n is equal to 4, and this is what we have here. We are going to use these identities here. So as you can see from these identities, we are working with sign, so you're supposed to be focusing on a sign here. So if we check, this is sine squared. So meaning to say we are supposed to write this in terms of what? Sine squared. In terms of sine squared. So this here is going to give us the integral of the sine squared of 4x with respect to x. But because it's to the exponent of 4, so to obtain that, we are supposed to square it again. So that 2 and 2 adds together, 2 plus 2, that's a 4. So we haven't changed our question. We still have the same thing, all right, with respect to x. This part here, we have the equivalent of it, sine squared. This is the one that we are supposed to substitute now. We said, because we said we're going to use these identities, and we are given here that sine squared ax is equal to half of this. So it means that our a in this case is what? Is 4. Our a is equal to 4. So meaning to say here we're going to multiply 2 times 4 times x, which is 8. So we are going to obtain the integral of, so take note, this is an identity for sine squared. We are just substituting where there's sine squared. We're going to substitute with the equivalent, all right? But this is sine squared 4x. So we're going to have 1 over 2 minus 1 over 2, the cosine of 2ax. Ax is 4x, so 2 times 4x is going to give us 8x, like this. So it will be half minus half cos 8x with being squared like that with respect to x. All right, so this is where we are now. Okay, so the question is, what are we going to do in this case so that we'll be able to integrate? There's an exponent of 2, we can see that, okay? So what are we going to do? Because we have given the exponent of 2. We are supposed to expand. Remember the concept of our expansion when we are given the exponent of 2. We are not going to waste much time, guys. We talked about this since we're doing our mathematics N3, N4, in fact, from N2, all right? We talked about this. Sorry for that. Need this part. All right. So we talked about this expansion to the exponent of 2, whereby if you are given I squared a minus, because there's a minus, a minus b squared is equal to a squared minus 2ab plus b squared. So what does it mean? This is the first term, this is the last term. So on your expansion, you're going to have the first term squared. This is what we have here. This is our a, so this is our first term, and this is our last term. So the idea there is that we are going to have the first term squared, which is 1 over 4 squared. That's our first term, right? Just a recap, because we have been talking about this. So that is 1 over 4. If you square 1 over 2, all right, then you have got minus 2ab. So what does it mean? It means we've got minus 2 times a. Remember, we said our a is 1 over 2. So it's 1 over 2 times b. Our b is this part of half. Do not take the sign. The sign is already involved. So don't take this sign. The b is this part, a minus b. This is your b. So you're going to multiply by half cos 8x. This is our b. So if we multiply this, definitely this will cancel. We get minus half cos 8x. So this will be minus half cos 8x. All right, then the last part is the last squared. B squared represent what? The last. So it's the last squared, meaning to say we are supposed to square 1 over 2 cos 8x like this squared. So that will be 1 over 2 squared. If we square 1 over 2, we get 1 over 4. It's 1 over 2 times 1 over 2, which is 1 over 4. cos, we are going to also square it. So it is going to be cos squared 8x because we have squared this x. So it's going to be cos squared 8x like that. All right. So that's it. That's how you expand this. You just apply your normal algebraic identities, those expansions of brackets that we used in our N3, N4. Or you can just expand 2 brackets, you expand them properly, it's up to you. But guys, it's gonna be a lot. All right, once you have expanded like this, we're done. We can integrate now. Now we can integrate everything here can be integrated if we check properly. We can integrate this, we can integrate this. So we are going to integrate the integral of 1 over 4 with respect to x is going to be 1 over 4x. Okay, minus 1 over 2, the integral of cos. Remember, cos changes to sine. So it's going to be sine 8x over the derivative of this 8x, which is 8. So you're going to multiply by this for that is outside, okay? Plus 1 over 4. Remember, we are integrating cos squared. So it's going to be 1 over 4 times the answer that we are going to get if we integrate cos squared. Like I said, there's no need for you to go back and use the identity again. We have the integral of this cos squared. I explained about this. So let us just go back to our formula sheet again. But if you check here, we explained about this. This is the integral of cos squared. So the integral of cos squared ax is going to give us x over 2 plus sine 2ax. So take note, if this is ax, here it's multiplied by 2. 2ax, you multiply it by 2 over 4a, meaning to say the number here that is multiplying x is the one that is now multiplying what? 4. So that is the one that we're going to take. All right. So let us take our integral and see. So this is how you integrate cos. All right. So let us integrate. Okay. I have many pages here. I'm seeing that I've placed a lot of pages. Sorry for that. Sorry for that, guys. All right. So we said the integral of a cos. It can be written like this. The integral of a cos squared. So I want you to see it properly. Cos squared ax with respect to x can be written as x over 2 plus sine 2ax, everything over 4a. So this is what we have here. This is exactly what we have, cos squared. Okay, so this is cos squared. So meaning to say our a, we're talking about 8. Okay, that is our a. Okay, so the formula is stating that if we integrate this, we're supposed to get x over 2. So that's x over 2 plus, it changes to sine. So it's going to be sine 2ax, meaning to say we multiply 2 times ax, which is 2 times 8x. 2 times 8 is 16. So that will be 16x over 4a, that is 4 times our a. Our a is the number that we have, which is 8. So this is 4 times 8, which is 32. 4 times 8 is 32. You multiply this 4 and this number, 4 times 8, that is 32. So that's it, plus the constant of integration. You are done. So at this stage, what you just need is the simplification, all right? Just have to simplify properly each and every stage that you are given. All right, so let us multiply, expand brackets and simplify together. I think that's gonna be fine. So here you're gonna get 1 over 4x. We multiply this, that will be minus 1 times sine 8x. We multiply the numerator, so that will be sine 8x over 2 times 8, which is 16. Okay, we move on here, we multiply again. This is 1 times x over this, 4 times 2, which is 8. So, or you can just write it as 1 over 8. So it's plus 1 over 4 times 1 over 2. It's 1 over 8. So this will give us 1 over 8x. Okay, plus 1 is going to multiply sine 16x. So it is going to be sine 16x over 4 is going to multiply 32. So it's 4 times 32, which is 128 plus the constant of integration. So in most cases, most of you ignore this, but if you check here, these two are like terms. This is 1 over 4x. This is 1 over 8x. So these are like terms. They can be added together. So we are going to combine 1 over 4 plus 1 over 8. If you add this on your calculator, this is going to give you 3 over 8x. All right, minus the sine of 8x over 16 plus the sine of 16x over 128 plus the constant of integration. So that's it. That's how we could have integrated this whole part. And don't forget the constant of integration. So this is how we could have integrated when we are given to the exponent of what? To the exponent of a 4. So like I said, this is the most important part, because for exponent of 2, it's a waste of time when it is an exponent of 2. Use the formula sheet direct. Don't work out this. I need to take this identity because I was told this, and no. It's not necessary. All right, it's not necessary. All right. So I just hope you get something from this. Let us see another way. Another question that we might be given, but this time we want to change the exponent. Let's talk about having odd numbers. Odd numbers, 3 and 5. Remember, we said for the odd numbers, we are going to see that we have got a 1 there. But when it is 1, that is our normal integral. That is the one that we are used to. All right. So this was our first condition. All right. So let us do this. So this was our first condition. If these are even numbers. So the second condition is of n is equal to 3 or n is equal to 5 when we are dealing with odd powers, which is odd numbers. When n is an odd number. All right, whenever n is an odd number, we are working with n is equal to 3 or n is equal to 5. This time, you're going to use this identity. We talked about this identity also before. We listed, I showed you these identities. So we are going to use the identity. All right, use the identity sine squared ax plus cos squared ax is equal to 1. So meaning to say, it's either you're going to work with the sine squared, make it the subject of the formula. If we make sine squared the subject of the formula here, it follows that sine squared ax is going to be equal to 1 minus cos squared ax. All right. If this is cos squared that you want to make the subject, it means cos squared ax is going to be 1 minus sine squared ax. So you can play around from this into this. So this is the identity that you are simply, it's one identity, but you can write it in the way that you want, provided depending with the question. So this is a condition whenever n is what? 3 or 5, whereby you're dealing with odd numbers. So you expand that in terms of sine squared or cos squared from what you are given. Okay, let's start with a simple question. I want us to start with a simpler question. Remember, I talking about a condition where n is equal to 3 or n is equal to 5, whereby these are odd exponents. All right, let us say we are asked to integrate with respect to x sine to the exponent of 3x with respect to x. This is what we are supposed to integrate. So if we take, we've got 3, which is an odd exponent, the n 3x is the odd exponent. So we are supposed to think along, apply this identity, which I said it can be manipulated to this because we are working with sign. We are supposed to think where there is a sign, you're supposed to think of this one. But how? Okay, In order for us to have sine squared, it means we have to expand because this is sine to the exponent of 3. We have to expand this in terms of sine squared. So it's going to be the integral of sine squared 3x. All right. We are expanding now the sine, the exponent of 3. All right. So it's going to be 3x here. In order for us to remain with to the exponent of 3 is going to be times sine 3x like this with respect to x. What have we done? What we want to achieve or what we want to have is either of these, but definitely we are talking of sine, so we are supposed to have this. Okay, it's not like a guesswork. We are supposed to have this sine squared ax. Why? So that we can have a substitution in place of this. We are going to replace because we need to use this identity. So how do you use it? You have to replace it, sine squared. We have to replace it with this identity. So this is going to be the integral of where there is sine squared 3x. This one is going to give us 1 minus cos squared ax, which is cos squared 3x as it is. All right. Times sine 3x, which is outside of the integral, outside of the bracket, but part of the integral, but just outside of the bracket. So at this stage, we can expand the brackets by sine 3x. I want you to see the miracle that is happening here. If we do this, if we multiply by this dx on each, separate by each integral, we're going to have the integral of 1 times sine 3x. It's sine 3x with respect to x, okay? Minus cos squared times sine this is going to be minus the integral of cos squared 3x cos squared times 3x times sine 3x with respect to x. This is what you're supposed to have in actual sense. This is what you're supposed to have. We have expanded this, but as we're expanding, separate them, okay? So that you'll be able to integrate sine 3x and also be able to integrate this. So as we can see here, it's easier for us to integrate now. Here we said, if we are working with a sine, the integral is direct. Remember the integral of a sine, it's a negative cos, okay? If we take a closer look where we had a sine, where the sine was being used. Okay, so meaning to say we can integrate this. Then we come back and integrate this one here. Guys, do not confuse this. Please do not confuse this. We integrate here and we do our integral there. We could have done it once, which is fine. Okay, let us integrate sine. We say sine changes to cos. So this will be negative cos of 3x over 3. Okay, minus, take a closer look of what is happening here. We are supposed to integrate this, but how? How can we integrate this? Okay, let us have this integral aside. We don't want this to affect our answer. So you do your integrals aside, then you just write the answers. You can just do your calculations aside. Here, we want to integrate this. All right, so this is it. The integral of cos squared 3x times sine 3x with respect to x. How do we integrate this? So there we are supposed to think of the substitution method. If we think along those lines, it can be easier for us, remember? So you can take this one with the exponent to be our u. So you can just choose, let u be equal to cos 3x. Okay, so if we let our u to be equal to cos of 3x, it means the derivative of u, remember your substitution from your n5, that will be the derivative of cos changes to be a sine, but this number multiplies here. So it will be negative 3 sine of 3x. And we make dx the subject, guys. Remember your substitution from n5. So you're going to make dx the subject. So it's going to be minus du over 3 sine of 3x. Right? So you cross multiply, you divide to make dx the subject. Okay, this is what you're going to get. And this is what you're supposed to like substitute here so that you can be able to integrate. So it means at the end here, you're supposed to get something of this nature. This will be, all right. Okay, let's just hope I didn't erase something that I want. All right. So this will be the integral of this, which is now cos it's u. Remember we said let u be equal to cos. So it's going to be u squared times the sine of 3x. But as you can see, it's going to cancel with this because this is negative du over 3 sine 3x. So this and this will cancel. We can get rid of the negative a third outside of the integral. So this will be minus a third the integral of u with respect to u. All right. So that will be minus a third integrate u squared. That's a normal algebraic. Gonna add 1. So that will be u to the exponent of 3 over 3, which is going to give us, if you multiply, that's going to be minus 1 over 3 times 1 over 3 is going to be minus 1 over 9. So that's minus 1 over 9 u to the exponent of 3. But we know this u. U is what? U is cos 3x. So it's going to be cos to the exponent of 3x. Okay. So this is what we are obtaining from the integral of this part. It is giving us this from the substitution method. We used the substitution method to integrate this. Like I said, guys, let us go back to our N5, redo the integration by substitution method. I explained everything there. All right, anyways, so this is the answer that you're going to get from that integral. We are going to get minus 1 over 9 cos cubed 3x. All right, so this is it. This is it. You are done. Here you're going to get minus 1 over 9. The integral of the whole of this part, we got minus 1 over 9 cos cubed 3x. So that's it, plus c, because we do not have anything to be integrated later on. So this is how you play around with your integrals, guys. All right, just have to pick the normal trigonometric identity that you play with. But later on, the integrals there, normally you're going to go back to the substitution, trigonometric, okay? And we talked about this, like I was saying, from our N5. So just be careful that you do your recap well, so that you'll be able to understand this. All right, so let us expand this. This will be minus cos 3x over 3. Expand negative is going to be positive, so it's going to be positive 1 over 9, positive 1 over 9 cos cubed. So this is cos cubed 3x plus the constant of integration at the end. So that is how we could have simplified this integral. As long we are dealing with, or as long we are working with what? With an odd. We are working with an odd. So we talked about working with an even exponent for that sign. We did an even exponent. Now this was an odd exponent where n is equal to 3. So you do this, guys. Try to apply this same idea, same knowledge. You see that you're not gonna go wrong. All right. So even for 5, you do the same thing, but you see that you're gonna integrate and integrate again. So what I want us to do is to combine everything at once. Whether it's an odd, whether it's an even, I want us to combine this at once. All right, so that we'll see how do they ask these questions, because this is it about this type of integral. We shall see another type in another class. Okay, so let's say we are asked to integrate. All right, integrate cos to the exponent of 4 of 3 over 2x with respect to x. All right. So with respect to x, this is what we have. Remember what I said, if you're dealing or working with even numbers, okay? This is an even number. 4 is an even number. So since n is equal to 4, what am I supposed to think of? I'm supposed to think of the identity of cos squared because this is cos. So I'm just going to write the one for cos. I wrote two identities there, but I'm just going to write the one for cos. Remember, I said we're going to use cos squared ax, okay, is equal to 1 over 2 plus 1 over 2 cos 2ax. All right. So this is the identity that you're going to have. Okay. So meaning to say there is a need because as you can see, there's a cos squared here. We remember we did this one with a sine. So it's a repetition that we're doing. So we are not gonna talk much because I'm not gonna talk much because we had the same thing. So we're just gonna write this in terms of a squared, in terms of cos squared. So this will be the integral of cos squared of 3 over 2x, but we are supposed to square this, right, with respect to x. Okay. Now, what is the equivalent of this? What is the equivalent of cos squared? Okay, let me do this. Let me try, maybe it's gonna make sense. What is the equivalent? All right, am I doing the right thing here? Why is it doing like this? Maybe it's, all right, no problem. No problem, as long as we see what I want you to see. Let's do this. All right, this part here. What is the equivalent of this? Because there are two things that we are considering here. Okay, what are the two things that you're considering? There is a square here. There is a square on cos. So the one that I want us to deal with is this one inside of the bracket, the cos squared x, this one. This is the one that you're supposed to use this identity, this one. So meaning to say here, cos squared of 3 over 2x is equal to, take note, our A here is 3 over 2. So if our A is 3 over 2, it's going to be 1 over 2 plus 1 over 2, the cos of 2 times our A, which is, or let us just say AX as it is, AX, which is 3 over 2x. So it's going to be 3 over 2x. So 2 times 3 over 2 gives us a 3. This and this will cancel, or just use a calculator, you're going to get a 3. So meaning to say at the end, this here is going to be the integral of this cos squared x. This one alone, it gave us 1 over 2 from the identity, our trigonometric identity, 1 over 2 plus 1 over 2 cos 3x. Remember, this canceled, so this is now 3x. So it's now cos of 3x squared. So everything has changed. It was 3 over 2x. Now it's 3x. It has changed. It has changed, all right? And I said that once you have this, you're supposed to go back to the expansion. This is it here. We have got a squared here. So we are going back a plus b, because since we are adding here, so this is going to be a plus b squared, which is equal to a squared plus 2ab plus b squared. So you're supposed to memorize this from your N3, like I said before. That is the first term, the last term. So what does it mean here? It means we're going to have the first squared, the first term squared. And our first term in this case is what? It's this part of, or let me try to use this one. No, it's worse. It's worse. But I have used this before and it was working properly. You guys, I don't know. I don't know who is praying that this video is not supposed to come out. I don't know. Okay, no problem. But I hope you see. I hope you see. So this is your B. This is your A. Once you understand this, guys, you are done, because you have your A, you have your B, and you understand this is going to be A squared, which is the first squared, A squared, which is 1 over 2 squared. 1 over 2 squared is 1 over 4. So this is going to be 1 over 4 plus 2ab. 2ab means 2 times A. Our A is 1 over 2 times B. Remember our B there is 1 over 2 cos 3x. So multiply this on your calculator, you're going to get 1 over 2, or just cancel this. you remain with 1 over 2 cos 3x. So this is going to be 1 over 2 cos 3x. All right, plus the last squared, meaning to say we're going to add the last squared, which is our last there, is 1 over 2 cos 3x squared. So if we square this, what are we going to get? 1 over 2 squared is 1 over 4. Then cos squared is going to be cos squared 3x. So we have used this exponent of 2. Everything is being affected. So you expand from this identity of our algebraic. Algebra also has identities, guys, as you can see. Algebra, it also has identities, just like trigonometry. So by now you ought to understand this, okay? I just hope we are on the same page. Okay, at this stage, it's now your integral. We're done at this stage. It is just our integral this time, okay? So let us integrate. The integral of 1 over 4x is going to, with respect to x, is going to give us 1 over 4x. So that's 1 over 4x plus 1 over 2 times the integral of cos. Remember, cos changes to a sine. So this will be sine 3x over 3. So this is cos, okay? Then I said on the integral of cos squared, there you are not supposed to go back and use the identities. No, use the integral straight from your formula sheet, all right? And I showed you this integral. I think we even talked about this as it is. Anyways, no problem. Let me just try to show you again here. On this one, we talked about this. The integral, I mean, these are the integrals. Remember, let's see here, these are the integrals as we saw from the top here. These are the integrals, okay? Don't forget, guys, these are the integrals. So if you're integrating cos, we are going to take this. We talked about this integral before, cos ax, cos squared ax. So our a, in this case, is going to affect the sine and is going to affect the 4, okay? So that is part, this one is just going to remain as x over 2, all right? So let us do this. Do I have to write this, guys? Okay, let me just write it down. For the sake of us all understanding, let me just write it down again. All right, anyways, like I said, let me just write it down. We are saying the integral of cos, it is given like this. The integral of cos squared ax dx is equal to x over 2 plus sine 2ax, all right, over 4a plus c. So this is what you're going to do. So this is where we are here. We want to integrate this. This is the one that we are talking about here. So we are going to have x over 2, okay? So that will be x over 2 plus sine 2ax. So this is going to be sine 2ax. 2ax, this is our ax, cos 3x. So it's going to be 2 times 3x. That is our ax. Everything over 4a. So that is 4 times a. Our a is the number that is affecting x, ax. So the number affecting x there is 3. Okay, so that's it. Plus the constant of integration. So we can simplify this further. 1 over 4x plus multiply. This is same as 1 over 3. So we have got 1 over 2 times 1 over 3. So if you multiply 1 over 2 times 1 over 3, we get 1 over 6. So this is going to be 1 over 6, or you just use a sine 3x. Just multiply the numerators together, guys, okay? Numerator together, you get what? Sine 3x. 1 times sine 3x is sine 3x over 2 times 3, 2 times 3, which is 6. Just like that, you're done. You move on, plus you multiply here, 1 over 4 times 1 over 2, which is going to be 1 over 8. So this will be 1 over 8x. Okay, you do the same thing, plus, here is a plus, and here is a plus. So you multiply 1 times sine on top. So this is going to be sine 2 times 3, which is 6. So it will be sine 3x over. So here you multiply 4 times 3. 4 times 4 times 3. Take note, 4 times 4 times 3. Multiply this 4 times this 4 times this 3, because it's 1 over 4, which is outside of the bracket, which has to affect everything. So this is going to give you 48. If you simplify properly, 4 times 4 is 16. 16 times 4, which is 48, or just use your calculator, okay? Plus the constant of integration. Like the previous case, we saw that here, and I explained that don't be tempted at this stage to leave your answer at this stage, because you can see that there is 1 over 4x, 1 over 8x. So these are like terms. They can be collected together. 1 over 4 plus 1 over 8, you combine them together. That is what you're supposed to do. This will be 3 over 8. So we are going to get 3 over 8x, okay? Sign remains as it is. We do not have any sign 3x, so it's going to remain as it is, all right? Sorry for that. Okay, sorry for that, guys. So this is just going to remain because we do not have anything corresponding to this. So this is going to be sine 3x over 6. Okay, then this one again is just going to remain as it is. We do not have anything corresponding to this part here. We do not have anything corresponding to this part. So it is also going to remain as it is, okay? So it is going to remain as it is, as sine 6x, sine 6x over 48 plus the constant of integration. All right, so that's it. We are done. There's nothing that you can do from this, okay? So this is how you play around your integrals, all right? If this is an even exponent, if you're given an even exponent, you have to choose your identities from the two that I gave you. When you're dealing with an odd number, you use the 1 for sine squared ax plus cos squared ax is equal to 1 whenever you're dealing with what? With an odd number. But when dealing with even numbers, you work with the one that we used here for cos or for sine, depending on the one that you have or the one that you're given for that particular person. Then from there, expand. Like I said, know your identities from your algebra, how to expand to the exponent of 2. It saves you time in exam. It saves you a lot of time. All right, remember, this is N6, guys, and you will see there is a lot that you have in your paper. So it saves you time to know your basic identities from your N3. So just find a week or 3 days or so, just to have a recap of these. You'll be in good books with your N6. You won't even have any mistake in your N6. All right, anyways, let us see this part. There they like I said, it's now we are now combining everything at once. All right, so they gave us something which is interesting. This one is an interesting question, actually. You see it. They're saying the integral of is sine to the exponent of 3x, all right, with respect to x, plus cos to the exponent of 3x, like this, with respect to x also. So this is an interesting integral. Some would think of factorizing, because we had, remember, difference of 2 cubes and also sum of 2 cubes in our factorization. But that one is not going to work. It's going to be a lot. So what is it that they just gave us here? If you check properly, they just separated us here and here, and this is an addition. And remember, under addition, you can separate your integrals. So they just gave you a double job to do, to integrate sine to the exponent of 3x with respect to x. All right, why am I putting this here? Sorry for that, guys. It's supposed to be there, here. To integrate this with respect to x, and also to integrate the cos to the exponent of 3 with respect to x. That is what the question was all about. That is what it's all about. So like I said, whenever you are dealing with an odd exponent, was this 3 is an odd number, we are going to use the identity sine squared ax plus cos squared ax is equal to 1. If you haven't applied this, ask yourself to say, am I correct? But I'm not saying you'll be wrong, like for now, like for what I've taught you now. I'm gonna, if time permits, I'm going to have a class with you guys with other methods that can be used. And there will be easier methods. It's only that our syllabus, yes, now they're trying to introduce these methods. If you check some of the memos, now they're trying to introduce these methods. They're trying step by step. Let's hope by earlier years to come, we shall have those methods fully approved in the syllabus. Okay, no problem. Let's see. Like I said, if you work out and you haven't applied this, then it means something is wrong. And in order for you to apply this, it means you have to make sine the subject. And I talked about this, that the sine squared of ax is going to be equal to 1 minus cos squared ax. The cos squared of ax is going to be equal to 1 minus the sine squared of ax. So meaning to say that you are supposed to make or to work with the sine and have a sine squared. Without a sine squared, it means you can't apply it. Without a cos squared, it means you can't apply this. So how can you have a cos squared? How can you have a sine squared? It means we have to separate this. All right. So let's separate. So this will be the integral of sine squared x times what? So that we remain with the same sine to the exponent of 3 times the sine of x with respect to x plus the same thing for cos. In order for us to use cos squared, it means we must have a cos squared. So it is going to be cos squared of x times the cos of x, so that it gives us back the cos to the exponent of 3. If you multiply this, okay, we just add exponent 2 plus 1, which is 3, 2 plus 1, which is 3. So we just have the same thing. So this is what we have. So now we can substitute back now what is equivalent to the sine squared of x. So the sine squared of x is equivalent to what? To 1 minus cos squared. If this is a, this is a. So if this is a 1, this is going to be a 1. So it's 1 minus cos squared x times the sine of x, which is outside, with respect to x. Plus, you do the same thing here, the integral of cos squared, which is cos squared is same as 1 minus. So this is 1 minus sine squared. So that's 1 minus sine squared x times cos x, which is outside. There's cos x, which is outside, with respect to x. Okay, this is where we are. We have used these identities, so they are no longer important. Let me just remove this part. Okay, this is where we are. So like I said, they're just punishing us, guys, to integrate this, redo it with a cos. But it's not a punishment. It's a learning thing that you learn. So I'm going to do this. Previously, I expanded, so it's an advantage also, because previously, I remember I expanded this and integrated 1, 1, okay? I expanded and integrated 1, 1. This time, I'm not going to do that. I'm going to introduce you to another calculation. All right, which calculation is it? This is what you can do. At this stage, all right, we're going to separate, all right? I'm working on this side here, on this side. You can choose your u from as it is like now. If we choose u to be cos, it means we can cancel the sign, because the derivative of a cos is going to carry a sign, and that sign is going to cancel with this. So we can choose our u to be a cos. So if we let our u to be a cos of x, the derivative of u with respect to x is going to be negative sine x. Remember, guys, we make dx the subject here is going to be minus du over the sine of x. All right. So this is what you're supposed to do in actual sense. You were supposed to get this back here. All right. You're supposed to get this back. You substitute the integral of, you substitute 1 minus cos squared of which cos squared in this case is this part of u, which is 1 minus u squared, times the sine of x. But if you check, guys, the sine of x and this will cancel. Sine of x and sine of x will cancel. But let us write the sine of x times dx. Our dx is the one that gave us minus du over, take note, this is minus du over sine of x. So this is what I was explaining. The sine of x and the sine of x will cancel. And you take the minus, which is on du, out of the integral. So this whole thing that we are talking about here, this whole part is, or can be written as minus out of the integral. Take note, we're going to take minus out of the integral. So you're going to integrate what? 1 minus u squared. 1 minus u squared with respect to u. But take note on this one, guys, be careful on this question. The u that I'm talking about here is this one, which we said it's cos. So we have to be careful because it is not the same as the one that you're going to use on this side. These are two different integrals, but done at the same time. Two different integrals, but done at the same time. So you have to be very, very, very careful there. All right. So we are going to finish here, guys, as you can see, but like I explained. So the u to be used here is this one for cos x. So you're going to talk about this. All right, let's do the same thing on this side. In order for us to cancel this cos x, to remove it, we have to make sure u is sine x this time. All right, so you're going to let, by substitution method, u is equal to the sine of x. Like I said, guys, please do also revise your N5, okay? We talked about this substitution method. So the derivative of u with respect to x is going to be the cosine of x. We make dx the subject, that would be du over the cosine of x at the end. All right, so if we get this as du over cosine of x, it means we're going to substitute this part. So in actual sense, it was supposed to look like this. I just want you to see how it was going to look like. It was supposed to be the integral of 1 minus, remember we said let u be sine x. So it means where the sine x I'm going to represent with u, so it's going to be u squared times the the cos of x times the cos of x times dx, of which our dx is du over cos x. So it's du over the cos of x. So this will cancel, cos x and cos x, we remain with this part. So this is the part that I want us to write here. So you're gonna have plus, so this will be plus the integral of 1 minus u squared with respect to u. But take note, like I said, the u that we are talking about here is not the u of this side. No, this u that we are talking about is the u, this one, which is sine x. So the u that we are going to work with here is the sine of x, not the cos. The cos is for here, this one. So be careful on that part. All right, anyways, let us integrate. This is where we are. And now we can use our normal. So this is, like I said, another way of integrating. Like I said, guys, if time permits, this means there's a lot that we can talk about. N6, there's a lot that you need to work with. Okay, anyways, let us see. So let us integrate this. So this is going to be minus, we integrate this. So that is the integral of 1 gives us a u. So that will be u minus u to the exponent of 2. We add 1. So that will be u to the exponent of 3 over 3. Okay, plus we do the same thing here. 1 gives us a u minus u squared, which is u to the exponent of 3 over 3. All right, plus the constant of integration. So like I said, the u of the first part here is cos x. So we are going to substitute cos x. So it's going to be minus u, which is minus cos x, minus it's a plus. So that's cos x to the exponent of 3. So it's cos to the exponent of 3x over 3. Okay, we do the same thing, plus times u. But the u on this side, the u of this part is this one for sine. So this will be sine x minus, plus and minus, that's a minus. So it's u to the exponent of 3, which is sine to the exponent of 3x over 3 plus the constant of integration. So that's it. So they just wanted to play around our minds here. Do you know how to integrate sine to the exponent of 3, of which I think we talked about this. What wasn't it sine? We didn't we talk about it? Yes, it was sine. We talked about this. It was sine to the, it was like this. It was sine to the exponent of 3 of 3x. We did this question with this one. So you see now they are combined. So meaning to say next time they will give you here with 3x and here with 3x, or maybe here with 4x and 4x. They just want you to see, can you do these integrals separately the same way that you used to do your integrals when they were or on each part, like you are working with each part separated. Are you able to do that? If you are able to do that, guys, like I said, you can be able to integrate whatever question that you are given in your syllabus. So that was it. Here we separate each and every part. We integrate each part, knowing that the u of this side is different as the u of that side. It's like you're working different questions, then you combine them at the final. That is what the question is all about. It's like you are given two different questions, then you combine them at the end. That is exactly how this question was all about. All right. So we never did an exponent of 5. Okay, I think so. We never did exponent of 5. Let us end with that one. Let this be our last question. The integral of sine to the exponent of 5. All right, sine to the exponent of 5 of 3x with respect to x. All right, there is an exponent of 5. Okay, when you are given an exponent of 5, remember this is an even, an odd number. And like I said, whenever you are using an odd number, you are supposed to think of this identity, sine squared ax plus cos squared ax is equal to 1. This is the one that you use whenever you are dealing with what? An odd number. Okay, just use one identity. So meaning to say you just have to make sine the subject, meaning to say sine, we explained this, guys, from the previous question, 1 minus cos squared ax. So meaning to say there is a need of us to have a sine squared from this sine to the exponent of 5. How can we write, or how can we have a sine squared? Okay, this is it. We're going to write this as the sine to the exponent of 5 is same as sine squared of 3x, like this, raised to the exponent of 2. But if we raise to the exponent of 2, what do we get? 2 plus 2. Remember, 2 times 2, exponent and exponent multiply. 2 times 2 is what? It's 4, not 5. So in order to get 5, we are supposed to multiply by another sine 3x. So that here we've got an exponent of 4 plus 1. 4 plus 1 gives us what? Gives us a 5. So that is it with respect to x. What is it exactly that we want to achieve? We want to replace sine squared, because there we say there's an identity that is equivalent to that sine squared. And what is that identity? It is of 1 minus cos squared. So this is going to be 1 minus cos squared 3x. So take note, there's a cos squared. There's going to be cos squared. Okay, so this is cos squared 3x with respect to, being squared, times the sine of 3x. This one is not even affected. It's just like that, sine 3x out of the bracket. So we removed this identity of sine squared with the equivalent identity 1 minus cos. But there's a square there. So we are back again to that identity that we talked about, guys. A squared minus b, a squared, a minus b squared. A minus b squared, we say this gives us a squared minus 2ab plus b squared, whereby I've got the first term squared. So this is going to give us the integral of the first term squared, 1 squared, which is our a. This is our a. Guys, should I do like the last time? Okay, let me just do it so that all of us, we move together. All right. So this is your a, and this is your, you take as it is like this. All right. Just take this part as it is like this. All right. So that is how you work out this. So this is our a, and this is our b, so that we have a minus b squared. So this is a squared. So our a is 1 squared, which is 1. Okay, minus 2ab. So it means minus 2 times a. Our a is 1 times b. Our b is cos squared. So it's cos squared, 3x. So this will be minus 2 times cos, which is minus 2 cos squared. So that will be minus 2 cos squared 3x. Then the last part is the last squared, b squared, which is the last term squared, which is this term squared. So if we square cos to the exponent of 2, 3x, and we square these guys, it means we've got a square and a square. So 2 times 2, that will be 4. So it's going to be plus cos to the exponent of 4 of 3x, like this, okay? So this is what we have with respect to x. All right, like here we are adding, so the exponent is like we're gonna have this, if this is a 3 like that, okay? We're gonna add. It's like we've got another cos. Sorry for that, guys, the way that I'm explaining here. Maybe I'm tired now. You add, okay, to get this. So this is where we are. Oh, I left something also, the sign. Yeah, this is the sign to show that someone is tired here. Like this, there's sine 3x there. Sine 3x dx, like this. Okay, this is where we are. So the question is, remember the last method that we just did now. This last method that we just did now, we had to introduce u because there was a condition where we can cancel everything. But on this one, it's going to be difficult. Look, here there's a 1. So if you introduce a u, what is going to cancel here? What are you going to cancel? So meaning to say, on this question, we are forced to separate each and every part. We are forced to separate each and every part. We multiply by the sine of 3x dx, each and every part inside of the bracket. So we are going to have the integral of 1 times this, which is going to be sine 3x with respect to x. Minus 2, all right? So you're going to have minus 2, you can even write out of the integral. We multiply cos and sine, so this will be cos squared 3x sine 3x. All right, we do the same thing. There's a plus there, plus the integral of cos squared and sine again. I mean, cos to the exponent of 4. So it's cos to the exponent of 4, 3x times sine of 3x. Everything with respect to x. So there we are supposed to have with respect to x here. All right, with respect to x. So we are integrating each and every part with respect to x, every part. So there we are forced, guys. There was no way. We are forced. But the previous question, it had an allowance for us to do that integral like what I did. But here we are forced to separate each. Now we can integrate each. But as we can see here, what is going to happen is that on this side, we are going to integrate the integral of sine 3x. Remember, sine is a negative cos. So this will be negative cos of 3x over 3, okay? Minus 2, we are supposed to integrate this. So let us just leave the minus 2 for now. We are supposed to integrate this, guys. And also it is the similar part that we have here. So meaning to say we are going back to that substitution method again on this part here. We are going back to the substitution method because here we can see that is the same format, cos squared, cos, sine, sine. This one is the same format. So the u is the same. So we can just choose u to be cos 3x, cos, so that it can cancel with this 3x, cancel with this 3x, all right? So if our u is equal to the cosine of 3x, it means the derivative of u with respect to x is going to give us negative 3 sine of 3x. Make dx the subject. Dx is going to be minus du over 3 sine 3x. All right, that's it there, okay? So what it means is that if we were to substitute back now these integrals, we were going to see that the sign of 3x here, the sign of 3x here will cancel with this sign 3x because it's in the denominator. You substitute back here, you substitute, it's going to cancel. So meaning to say we are going to take the minus 1 over 3 out of the integral, where here there's a negative 2 already. All right, there's a negative 2 already there. So this is going to give us something like this. Negative 2, negative is going to be positive. So it's going to be positive 2. The integral of cos squared, of which cos is what is u. So it will be the integral of u squared with respect to u now. Okay? We have substituted dx already. We have taken already this sin x. It is cancelled. Sin x, like I said, it's going to cancel. All right? So this will be, this is 2 over 3, sorry, 2 over this 3. So it is the same thing here. Minus 1 over 3 multiplies what is outside here. So it's going to be minus 1 over 3. The integral of cos, which is u, to the exponent of 4. The sine 3x and the sine 3x was going to cancel. And we remain with dx here in place of this, I mean with du. So if you integrate now, what are you going to get on u to the exponent of 2? That will be 2 over 3. U to the exponent of 3 over 3 minus 1 over 3. Integrate this u to the exponent of 5 over 5. All right, plus the cost of integration. We're going to talk about that. So now you can substitute the cost that we have here, which is going to be 2 times 2 over 3 times 1 over 3. It's going to be 2 over 6. So that's 2 over 6 cos to the exponent of 3 of 3x. Okay, plus, sorry, there's a negative there. That's negative 1 over 3 times 1 over 5. So negative 1 over 3 and 1 over 5 is going to be 1 over 15, negative 1 over 15. U, it's cos. So this will be cos to the exponent of 5 of 3x. So this is the integral that we are going to take from the whole of this part here, the negative to this one, the whole of this part. You are supposed to use substitution method because it's similar, it's the same thing. So meaning to say, if we integrate the whole of this part, we are going to get this answer. So this is the one that I'm just going to write here. So we got here 2 over 3, 2 over 6. Where am I getting 6, guys? This is 2 over 3, not 6. Or okay, we simplified this later on. It was 3 times 3, 9, not 6. 2 times 3, that and 9. Guys, now I'm tired. Let me finish, guys. Let me finish. I'll end up giving you poison. 2 over 9 cos to the exponent of 3x. Okay, and this gave us negative 1 over 15. Okay, let me finish, guys. Let me finish. Minus 1 over 15 cos to the exponent of 3x plus the constant of integration. All right, so that is what you're going to have. So that was, it was a 3 times 3 because that was a 3 outside and another 3. So 3 times 3 gave us a 9, not a 6, guys, okay, because there was a 3 already there. And the integral of this 3, there's a 3 already. So this is how you play around with these integrals. So meaning to say, you're supposed to be good at your substitution. You're supposed to be good in your substitution method, the application of your substitution method. You're supposed to be very, very good in that. How to simplify using substitution method. You are supposed to be well equipped and also to know the equivalent part to use. So guys, please make sure that you subscribe to this channel and also share these videos so that they do help someone outside there, help Africa grow as a nation, as a continent of Africa. We want to grow and reach the whole of Africa if it is possible. So let us continue to share our platform to our friends and colleagues. But that's it. Integration for mathematics N6, netted engineering.